Greetings and welcome. Thanks so much for joining. I'm Nader Nanjiani with AWS Public Sector Marketing, and we are pleased to have you with us for our Raise the Bar on Data Protection with AWS Cloud Storage webinar series. Our topic for today is disaster recovery, and we have with us two of our technical speakers who will be diving deep into this topic and sharing with you their insights. Randy Stevens, who's our solutions architect for storage, and Daniel Covey, who's a technical specialist on disaster recovery. So without wasting much time, I'll hand over the conversation to our speakers. But before I do that, I want to remind you, if you have questions that come up, please go ahead and ask us by entering it in the Q&A panel, and or chat for that matter. And if for some reason your questions aren't covered during the course of the conversation, then you will hear back from Randy or Daniel in the form of an email. So you get a response by email after the fact. So with that being said, it's over to you, Randy, to get started with the presentation.
Thanks, Nader. And as Nader mentioned, today's topic is disaster recovery. And just for a little background, I am a storage specialist with over 30 years in enterprise, block, file, and cloud storage. And I've specialized in high performance storage and disaster recovery. With me today is Daniel Covey, who is a Cloudender disaster recovery specialist. First off, I will start with some background on how AWS views the cloud, then move quickly on some popular disaster recovery solutions and implementations that we've done here at AWS. Some of the DR solutions you'll see today are made from native AWS services, but most of them are partnered with independent software vendors, some of which you may have heard of, but many of which you may not know have a really tight AWS integration for disaster recovery. After that, Daniel will cover how a Cloudender disaster recovery works and present a live demo for you. We'll answer a few questions at the end, and if we can't get to yours in the session, we can certainly handle those questions offline, as Nader said. There's a quick survey at the end. You can enter your questions there, and they'll get responded to within a few days. So without further ado, let's take into a look at the cloud background. What is the cloud? Let's define it. As Socrates is credited with saying, the beginning of wisdom is the definition of terms. So let's ground our discussion by first defining what we mean by cloud and disaster recovery. Once we're all on the same page, we'll move into some real world DR implementation. The term cloud really refers to service rather than an infrastructure-based abstraction. You can have or run a private cloud or be a member of a community cloud. For example, AWS runs Gov Cloud, and the US Treasury Department has, for example, a workplace community cloud too. Public clouds, by definition, are provisioned for use by the general public, and we're seeing a lot of interest in implementation lately of the hybrid cloud. So what is hybrid? Hybrid's most common implementation consists of on-premises infrastructure coupled with a public cloud provider. In that case, the on-premises infrastructure is probably not managed as a cloud, but as a regular legacy-based infrastructure. However, it is possible to marry on-premise cloud-based abstractions like object storage. Perhaps many of you there have object storage on-premise with the public or community cloud. So that's a very popular situation. Now let's look at the scope of cloud use cases. Of course, the cloud is an easy choice for new greenfield applications, but for existing applications and environments looking to leverage the cloud, where's the best place to get started? Well, backup is very popular because you have access to unlimited tiers of storage, and it's all automatically contained off premises for survivability. Archival storage, for example, tape replacement, likewise is very popular and can unlock cloud-based services like analytics. Test and dev is another obvious one, along with hybrid. Here, hybrid is defined as extending the resources of an on-premise data center. Today, however, we are talking about the number one or perhaps the number two most popular use case, using the cloud for disaster recovery, which has the most potential for cost reduction by eliminating a colo site or a data center essentially that exists for geographical redundancy. In that case, the secondary data center probably holds servers, switches, and other gear that really only get used in a disaster or disaster recovery exercise. By leveraging the cloud for DR, you can get the physical and geographical separation you need in a pay-as-you-use scalable environment. And as a bonus, you can leverage the data in the cloud for many different use cases and services, like AI-based analytics. So not all cloud providers are created the same, and I'd be remiss if I did not introduce AWS as a public cloud provider. AWS, as you can see from the Gartner slide there, is far and away for 10 years the industry leader in public cloud for many reasons. One is the availability zone and regional architecture on which AWS builds services. And I'll cover that so that you can understand in a DR environment how that applies. It is an architecture that makes DR in the cloud easier because many of the services that we have are actually replicated across data centers inside of an AWS region. Next is the dominance of S3 as an object standard. There are over 100 different ISVs and even storage hardware and cloud vendors that offer S3 support or interoperability. You simply cannot go wrong with S3 as an object level abstraction. So let's look at that availability zone and region architecture. An availability zone is a collection of closely related data centers, you might call them a campus, that AWS manages. They usually exist within a few miles of each other. Multiples of these AZs, each less than 60 miles separated and having independent and power and network, comprise a region. At least 3 of them, and sometimes as many as 5 or 6. Regions have transit gateways or backbone connections to other regions. Of course, all traffic in this architecture is encrypted. And services offered by AWS, for example, S3 that I just talked about, or elastic file storage, which we'll cover, natively are redundant across AZs, thus surviving the loss of 1 or 2 AZs. In addition, it is possible to configure some services for automatic region-to-region replication, thus ensuring operation even on the unlikely event of a regional failure. So as you might imagine with this architecture, DR in the cloud of the cloud is a very easy reach. It's the hybrid situation that we are actually here to explore today. So, speaking of those regions, this is a quick overview of the regions that we have currently in the world, and there are 24. There are 77 availability zones and 1 local region in Southern California that operates essentially as a store and forward for media rich workloads. And there are over 200 point of presence, which you can hop on the AWS backbone from. And something I wanted to cover that you may not be aware of called AWS Wavelength, in which AWS provides services co-located with 5G service centers. Of course, 5G is certainly going to be near all the major metropolitan areas, and that really enables you to do some very low latency access to AWS services, which can come in handy in a DR for a very low RPO. So one other bit of regional information I wanted to cover was the AWS Gov Cloud. We have 2 regions, East and West. Of course, Gov Cloud is a community cloud that is designed and operated exclusively for government and government-related organizations. If you're in a governmental organization, you can use Gov Cloud as your region for DR or for any other workload you might have. One last slide about the AWS Cloud before we move on to DR is the core services. As any public cloud provider, AWS has lots of services. In fact, we have well over 200. So I can tell you I worked very hard here to reduce this slide to the absolute minimum in order to describe service types. In any disaster recovery, you must restart compute, and our native offering is something we call EC2, Elastic Compute. Your DR plan must somehow envelope or orchestrate starting workloads in EC2, depending on your approach. You can connect to AWS for DR purposes through either a direct connect, which is essentially a private link, or a VPN across the internet. Some stacks that you run on premise are available in AWS as a service, for example, databases. So a DR plan should decide how database recovery is mapped into the recovery plan. For example, you can use database as a service, or you can mirror your own database environment as part of the DR. Of course, the heart of a recovery is based on storage. As you can see, there are many options in AWS. S3, object storage, has 6 classes of storage that can meet any cost and availability demand. Elastic block storage is a drop-in replacement for on-premise block-based volumes, and EFS, called Elastic File Service, is likewise an NFS-compliant POSIX scalable thin provision file system. What do I mean by thin provision? When you create a managed EFS mount, for example, you see a 8 exabyte file system. But in true pay-as-you-go fashion, you're only charged with the actual written data. If you only use 100 gigabytes, you're only charged for 100 gigabytes. By the way, both of these are multiple AZ services, the S3 and EFS, so they're highly available. We also have file services called FSX for Windows, which is a managed, deduped, compressed, 100% Windows compatible file service that can extend all the way back to on-premise. AWS Backup is a built-in backup service that you can back up most AWS resources, including databases. Lastly, security is indeed here at AWS job one. You can control every aspect of the key generation, key storage, and key rotation, and we have a built-in identity management service. I know how important security is in the light of today's events. If you're interested in our complete security profile, we can have specialists that can help you navigate the security concerns on your disaster recovery journey. And now, I think everyone knows that disaster recovery is a very hot topic this year after recent events. And disaster recovery is nothing more than the art of gracefully recovering your business operations after an unplanned disaster. Very easily said, but can be very hard to do. To successfully recover, though, although the disaster may be unplanned, your recovery must be planned well in advance. Here at AWS, we're a firm believer in documented plans, procedures, and regular disaster recovery exercises. What the year 2020 and 2021 have taught us about DR is twofold. Firstly, if your recovery model is based on a colo data center or cold sites, which you have very little manpower, during some disasters, you may not be able to travel to those colos or data centers to recover. That's a big, big reason cloud-based disaster recovery is being adopted by many organizations. Secondly, the increased reach of rogue actors and rise of ransomware has led many organizations to consider, for the first time, adopting a disaster recovery solution. But they are looking to avoid the cost of a second data center. So that's a really good use case for the cloud as well. So now let's define a little bit of what we determine as a disaster recovery scenario. I think most people are familiar with the concept of tiers. You can see this at the bottom of the slide. And you're probably familiar with recovery time objective, the time it takes to recover, and recovery point objective. Tier 0 might be described as mission critical, while Tier 3 historically is data that you need for long-term recovery, but is not used for the daily business operations. So you may be able to restore daily operations and then over time restore your Tier 3 data. Overlaid on top of that spectrum is how AWS describes the various data recovery scenarios that you might implement to achieve and meet those requirements. Note, of course, that your organization probably has all 4 tiers of data, and your disaster recovery solution should address each. For our talk today, we'll describe 4 different types of disaster recovery approaches, by the way, which can be combined. The simplest and most cost-effective is recovery via backup and restore. And that has the widest support by AWS and ISVs, but it has the longest RPO and RTO. Next up, Pilot Lite combines backup and restore with keeping some online replication going for business critical applications so that they might be easily restarted in a disaster, meaning other applications and data is restored from backups. The advantage here is that although you do have some servers continually running in AWS, it's a skeleton crew only, thus controlling cost. In a warm standby mode, You can have a scaled down version of your infrastructure application running in AWS and can use, for example, auto scaling or orchestration to ramp up the numbers of those or add to those servers to take the full load in the event of a real disaster. Likewise, you can restore your tier 3 data from backups as needed once you get going. Finally, in hot standby mode, aka multi-site, the application is essentially active-active between your on-premise site and AWS, which makes for seamless recovery. This is the most expensive option, but could be financially advantageous if, in addition to adding DR, you can avoid adding more resources at your primary on-premise site, perhaps because you're out of power, space, or cooling there. When it comes to disaster recovery planning, mistakes are often made by either going too big or too small. In situations where your DR plan is robust and outpaces your RTO and RPO, you're likely spending too much money on the services that are overkill. The 90% rule certainly applies here. On the other hand, if your plan covers too little and you fail to meet your RTO and RPO, you could fall into trouble by violating your SLAs or other agreements, and it may well damage your organization's reputation. Creating a successful disaster recovery plan takes work. If your IT staff is unsure, or if they're unsure or how to properly plan for a worst case scenario, bring in a trusted partner who has the expertise that can help you guide your staff in the right direction. I'll cover a list of those certified business continuity disaster recovery partners that are AWS certified later in this presentation. Not only can they help you choose the right plan, but they can help you identify what needs to be included and how to best set up your disaster recovery solution in AWS, while at the same time minimizing ongoing cost. So what are some of the big considerations when you want to implement a cloud-based DR solution? And this applies very generally. You want to consider what applications need low RPO and RTO, because those will be the most difficult. And you want to consider if any zero RPO solutions are needed. Also, you want to consider what type of orchestration that your disaster recovery plan has. Failover and, of course, failback is important when the disaster is over. The ease of a DR exercise. Back in the days, older days, it was often not possible to do a DR exercise that was really the same steps and plan as you would execute in a real disaster. Most modern implementations now, the DR exercise is the same procedure and plan as that you implement in a real disaster. And that's very important to be able to seamlessly execute your disaster recovery plan in the event of a real disaster. Next up, legacy compatibility. Is your disaster recovery plan, the method that you're going to go after, is that really compatible with what you have on premise? Well, you have to do some refactoring. So a lot of people want to avoid refactoring, so they go for something that's highly compatible with their legacy environment. Another issue is performance assessment. When you do fail over, you'll want to make sure that the performance that your applications need is available in the cloud. So that's really a configuration consideration, and there are tools that help you do that. Control plane location. Where does the control plane for this orchestration, for example, run? Is it in the cloud? Is it on premise? Can it be both? Is it hypervisor centric? Is it support your particular hypervisors? Does it lock you into a hypervisor? Low cost staging. What do I mean by low cost staging? If you do full upper level replication, it may take significant resources in the cloud to be able to land that replication. However, some more advanced solutions can land that on very low cost storage and then hydrate that later. So that's what I mean by low cost staging. It's definitely an economics play. Integrated backup. So the solution may or may not have integrated backup, or it may use your existing backup provider. So that's a consideration as well. And lastly, cloud independency. So, you may be using on-premise cloud, and you want to be able to choose your cloud provider of choice. So cloud independency, many of these ISVs are even AWS native are actually cloud independent, and we'll cover that in a little bit. So that brings us to the landscape of AWS disaster recovery solutions. On the right side, we have the vendors that can provide business consulting and DR help. Now, one thing I will say, this is an incomplete list. There are more vendors on the right and the left than I'm showing here. This is primarily done for the sake of time and screen real estate. We'll take a brief look, for example, over on the right at SunGuard in the respect of someone who can actually execute the disaster recovery plan, as well as help you provide the planning. So they can actually, in the case of a real disaster, execute the plan. We won't cover AWS professional services that they do, but they do that as well. On the left side are vendors that provide solutions, technology solutions. And I'll give you a quick overview of DR solutions that work well with AWS from VMware, Commvault, Netapp, Zerto, and Veritas. And of course, Daniel will cover Cloudender in both detail and demo. And I want to spend a little bit of time on this eye chart slide as a background. This is the first two use cases that I mentioned, backup and recovery and pilot light solutions. And you can see here that you have something called AWS Direct Connect or VPN Gateway or the internet to connect to the cloud. Maybe there's an S3 connection that goes across that as well. And you may actually be doing replication from third-party ISVs as well. And that's the generalized architecture. You can see some of the vendors there listed. So as you see there, you can replicate to S3, and there's Amazon Elastic Block Store, EBS, and you have a cold VM over there as an EC2 instance. And that would be restarted or started in the event of a real disaster. So that's warm backup and recovery or pilot light solutions. Most of the resources are stood down in AWS and thus don't cost you anything to run on a daily basis. In a warm standby or hot multi-site, you do have some running VMs in AWS. You can see those over there on the right-hand side. So overall, the architecture is very similar, but there are just more VMs that are running and more data that's hydrated to enable a lower recovery time objective. So now let's jump into the first, which is a native AWS-based disaster recovery. AWS has a product called Storage Gateway. You may be familiar with it. It can hybridize and cloud enable file, block, and tape storage. Backups thus can exist in the cloud. In this case, they exist in S3, which is multi-AZ, as we talked about. Although Storage Gateway is primarily designed as a cost reduction, data mobility, and backup device, it can be used as a basis for a simple backup and recovery cloud DR. In a real disaster, IT would start up EC2 instances and provide the correct backup to be hydrated for the application. So there's essentially no orchestration. You'll provide the orchestration either from another ISV or your own scripting. So this is the simplest and most cost-effective solution. Now let's move on to another type of backup and recovery, Commvault. Many of you out there are familiar with Commvault, and so it's not surprising that I might say that Commvault can do that. They do a great job and always have of reducing your backup windows while deduplicating and compressing backups. In this example, you can see there's a local disk pool, which you don't have to have, but I'll show it there, that gets replicated eventually to S3 and even leverages Glacier directly for cold data. So it's a very efficient use of the AWS storage resources while being feature rich in terms of plugins for backup. For example, another example is Commvault supports S3's object locked in Glacier, which ensures ransomware protection. So how does Commvault provide pilot light and warm recovery capabilities? You probably don't really know how that occurs. There's actually an option called Live Sync, which not surprisingly is online replication. So you enable Live Sync for the VMs and backup sets you want to protect and have on pilot light. Live Sync also does some orchestration and converts your VMware Hyper-V or VMs to an EC2 instance on the fly. Commvault even supports hot sites with something called the continuous data replicator. I don't have time to cover it here in detail, but I can assure you that Commvault can be a big part of your DR solution or the DR solution as a whole. Let's move on to another thing that a lot of people don't think about when it comes to DR, and that's Netapp. Netapp has cloud volumes, and so you can leverage Snap Mirror. You can do snap mirrors, or you can asynchronously replicate. Technically, this is warm or hot migration. As you can see, you must have fully running Netapp cloud volumes to land the replication. One advantage of the setup is that setup is incredibly easy. There's a drag and drop interface, for example. On-tap volumes costs can be reduced by tiering to S3. Netapp can handle block replication as well from Netapp sources. When replicating via Snap Mirror, the data goes automatically to S3, and if you're replicating asynchronously, the data first goes to our Elastic Block Store for 2 days, then gets tiered off to S3 to save on storage cost. Of course, your app-aware snapshot plugins will work in AWS during a real recovery, just like they will on-prem. Most deployments team Netapp with an upper layer orchestrator. For example, maybe you're using Netapp and you're using SRM. That's certainly a possibility, and we'll cover VMware in another slide here shortly. I want to move on to talk about the Veritas Resiliency platform. Not a lot of people are aware about this, but it is an all-inclusive cloud-based disaster recovery solution and orchestration software that includes a built-in data mover. And what's unique here is that it supports all the popular purpose-built on-premise storage arrays you might have. For example, EMC, HPE, Hitachi, IBM, Netapp, Infinidat, Pure, just about everybody that manufactures purpose-built storage arrays. It's fully automated and offers easy management and failover to AWS, fail back from AWS, and even non-disruptive disaster recovery testing. And here's something unique. It implements separate controls for each of the 4 user-definable tiers of recovery. You know, those tier 0 through tier 3. VRP integrates with Amazon S3 as well as EBS, giving you the choice in the type of storage, block or cost savings with S3. And this gives you the ability to recover complex applications faster. VRP performs a hypervisor VM conversion to EC2 on the fly, and it supports that back the reverse when you fail back. With VRP, you can achieve near zero RPO and ensure ransomware protection is part of your DR solution. Now I want to cover something that I mentioned earlier about SunGuard, availability services. You're probably familiar with SunGuard as a leader for over 30 years in disaster recovery as a service. SunGuard Availability Service is an advanced technology Amazon consulting partner, and they can provide a managed SLA-backed cloud recovery to AWS service, enabling Cloudender's technology. It's based on Cloudender, and Daniel will talk you through Cloudender here shortly. So SunGuard it's fully managed and backed by an SLA that can be as low as sub 1 hour. Technically, the RPO and RTOs as low as 15 minutes. And so you can do recovery from your premise to the AWS cloud, from SunGuard's premises to AWS, or from an AWS region to another AWS region. Now we're going to move on to hypervisor-centric replication. And here are 2 providers, Zerto and Veeam. Like Veritas Resilience platform, these provide a complete, although VM-centric, disaster recovery solution. They both started life as a VMware hypervisor plugins, but they've leveraged their I/O virtualization technology to enable a host of features on a wide variety of platforms. The Zerto platform is based on a foundation of continuous data protection, replication that brings together disaster recovery, data protection, and orchestration into a single pane of glass with support for any combination of on-premise and cloud-based environments. It replicates at the hypervisor layer, enabling the leveraging the I/O virtualization inherent in vSphere and Hyper-V, and it replicates directly to S3. Zerto can launch small helper instances to lower the recovery time for selected instances by hydrating that S3 to, for example, EBS. A good reference here is the Premier Healthcare. They replicate over 600 VMs with Zerto directly to AWS. Veeam started as a hypervisor-centric offering and has expanded to backup and disaster recovery. Like Zerto, it fully orchestrates the entire process and provides a single pane of glass. Each have their own particular strengths and should be considered for VM-centric environments. Here you can see a AWS reference architecture with Veeam that efficiently backs up and replicates VMware VMs to AWS 3. So that's a backup and restore DR. This provides a DR capability that's low cost, fairly low RPO, and is easily implemented in VMware environments. And you can find more about that in the Maritz case study link there below. Both Zerto and Veeam can provide the full gamut from cold to active multi-site. Now I want to move on and mention a provider you may not be aware of called Rubik. They're kind of a born in the cloud environment. And they're capable of warm and hot scenarios while simplifying the protection of applications, databases, hypervisors, and clouds to derive business resiliency, cloud mobility, and regulatory compliance. Rubrik Cloud Data Management Platform delivers backup recovery, disaster recovery, replication, and here's something unique: search, analysis, and analytics, and copy data management, all on Amazon Web Services for both cloud native and hybrid cloud applications. So they started in the cloud, but they've moved to where they provide these services on-prem as well. Rubrik encapsulates application data with rich services, including policy, security, access control, and compliance across your entire environment. Now I want to cover something that's very popular, VMware Cloud on AWS. Yes, VMware has ESX servers that they manage and sell as a service, all based in AWS regions, including public and community clouds like the AWS Gov Cloud. You can consume VMware Cloud on AWS as an on-demand disaster recovery offering to lower your cost. So obviously, it's a big easy button if you want to extend your existing VMware-based infrastructure onto the cloud, essentially creating a second data center. But we're here to talk about DR. We have something like 12 reference architectures with the VM Cloud. Here you see a couple of them that are enabled, like backup and restore, Pilot, and of course with replication, you can do warm and hot, just like between any two data centers and any VMware environment. In this case, one typically uses SRM for orchestration, and that means no learning curve required, nor are there any VM conversions involved. This is really the big easy button and is the quickest way to cloud enable your VMware environment. We've got a lot of customers that do this. So one case study that I'll show for you, let's see if I can get this to populate, is Discovery Channel. As you might imagine, they're a storage-heavy organization that needs to be up 24/7 by 365, and they moved their entire DR environment to VMware Cloud on AWS. They continued to use their site recovery manager for orchestration, just like I mentioned before, and also they leverage Net Backup to S3 for their non-mission critical workloads. So this is a good example of combining those types of DR scenarios. They were in fact able to build a complete end-to-end DR solution and enable an RTO of as little as 12 minutes. Due to AWS's flexible networking, Discovery did not have to reassign IP addresses for that. So that makes recovery a lot simpler for their core services. And with that, that's the end of my short survey on DR approaches in AWS. Please keep in mind there are many, many more options, and of course, you can combine these approaches to meet your needs. Let me also emphasize that you're not alone here. We have specialists here at AWS that can guide you on your DR journey. Don't forget, you can also leverage our consulting partners for design and our professional services, or SunGuard for DR execution in the event of a real disaster or disaster recovery exercise for that matter. Now, I'd like to turn it over to Daniel to talk more in detail about Cloudender. Daniel, take it away.
Thank you for the introduction, Randy. My name is Daniel Covey, and I am one of the Cloudender solutions architects with AWS. Today, I'm going to be going over the Cloudender DR tool, which is a block-level replication tool that allows you to replicate from any source infrastructure into AWS and then fail back after a disaster has occurred. So what are the highlights of the Cloudender solution? So it is any source into AWS, so you can do physical machines, virtual machines, VMware, Hyper-V. You can also do cross-cloud from other cloud providers into AWS. You can even do inter-cloud replication. So if you wanted to do DR from one region to another, or even one availability zone to another, Cloudender can assist with that. It's also non-disruptive to production. So we have a very small footprint on the source machine. It does not require a reboot when you install the agent on the machine, and it runs as lowest priority. So if the agent detects that the source machine is becoming overloaded, maybe due to a push and changes, we will actually back off of replication to ensure that the production server is not affected, and then pick up replication again once the load has subsided. You only pay for what you use. So as with all other AWS services, you're only paying for the time that the agent is actually running, and it's makes it so that you're not paying for services that you're not using. It's only being charged for when it's installed and protecting that source machine. We have an RPO of seconds, an RTO of minutes. So what that means is that since we're doing continuous block level replication, anytime a block is written to disk, we're then copying it across into AWS. So that allows us to have that low seconds, even sub-second RPO to ensure that you are fully up to date with your DR solution. And then we have an RTO of minutes. So usually it's about 10 to 30 minutes, depending on the operating system and size. And that allows you to fail over as quickly as possible and have the least amount of downtime available. We also have point-in-time recoveries. So should you not want to do the most up-to-date, maybe you've got something like ransomware and you need to restore from an older snapshot, you can absolutely do so. There's 61 recovery points. So you've got your latest every 10 minutes for the hour, every hour for the past day, and then every day for the past 30 days, which is also configurable to your desires. And then it's automated failover and fail back. So one of the great things about Cloudender is that we handle making sure that the volume is usable within AWS, and you can tell us how, in what order you want the machines to come up. So it makes it very simple to plan out what your disaster recovery solution is going to look like, and then have that kicked off in an automated fashion. Now we do have a wide platform support. This is just a visual chart of some of the applications and databases that we cover. In the end, it's a block level solution. So we're not really too concerned about what the database and application are because we're not aware of them. As long as it is a Windows or Linux x86 machine, we're able to assist in protecting that within AWS. So how does Cloudender disaster recovery actually work? So on the left-hand side, you'll see that you've got your corporate data center, any cloud, basically your source infrastructure. We've got two servers that we've installed the Cloudender agent on. The first server has 3 disks. The second server has 2 disks. Once those agents are installed, they're going to make a handshake with the Cloudender SaaS console over port 443. And that's going to tell the SaaS console, I'm installed on this server, here's the operating system, here's the disk count, what the disk looks like, giving us an overall configuration of that on-prem machine so that we can start building out the staging area. You'll see here we're also creating our staging area. So you've got your lightweight Linux instances. These are T3 smalls by default. And you've got your staging EBS volumes. So for every volume that you have on-prem, Cloudender will spin up a EBS volume to match. So we've got 5 on-prem. We now have 5 EBS volumes in AWS. And then we will spin up 1 T3 small instance for every 15 EBS volumes. So since we only have 5 volumes here, we're only going to have 1 T3 small. If we have more than 15, we'll have 2 T3 smalls, 3, 4, etc., based on the amount of EBS volumes that we need to cover the on-prem volumes. This makes it very simple and very inexpensive to have running during your normal operations. You're not having to do a one-to-one replication, one-to-one storage, one-to-one production server instance size. So it's a very cost-effective way to ensure that you're fully protected during your normal daily operations. Now you'll see here, we also have continuous block level data replication traffic. This is over port 1500. It is encrypted 256-bit in transit, and that goes directly into the staging area within your AWS account. Now, by default, it's not encrypted when it lands in AWS, but you can use the Cloudender tool to utilize your KMS keys and encrypt that data within AWS. Now that's going to be your normal daily operations. You've got your on-prem, you've got your staging area. As changes are made on-prem, it's replicated to the staging area so that you know that you will have a second copy of your data within AWS. Now, what happens during a disaster? So you're able to go to the Cloudender console and tell us to either do a test or a true failover. Also available via APIs. So you can build that API into a larger DR playbook if you would like. And we'll utilize APIs to launch your machines in the target subnet. That's going to be based on the blueprints, which we'll go over in just a minute. They'll tell us exactly what these instances should look like. And we'll go ahead and launch those, attach them to a machine converter, which we spin up for you. And that will do all the boot driver injections and just make sure that those EBS volumes are actually able to be ran as AWS AWS instances, and then attach those to the instance types that you've defined within your blueprint. Okay, so give me just a moment now, and we'll go ahead and show you a live demo so you can see kind of what exactly here I'm talking about. Okay. All right, so what we're looking at here is the Cloudender console. So this is the external console that you can log into and see all of your projects. So we are project based. You've got the ability to create as many projects as you would like. This can be different application workloads. It can be different business units. It can be multiple server types, depending on, it's all very flexible on what you would like to see. Now, in this particular project, we have two servers. We've got a database server and the WordPress front end. And these are in continuous data protection mode. So this lets you know that every time a block is written, we are capturing that, and we are fully up to date with all blocks that are on that server. Should something happen and we're no longer in sync with that on-prem server, maybe there's a network issue or the site has gone down, you'll see lag, and it'll tell you how far behind in lag you are from real time, maybe 10, 15 minutes. And then it'll tell you how long it'll take us to catch up to real time based on the current replication speeds. So what I'm going to do is I'm going to select these two machines, and I'm going to actually launch these right now. Because like I said, it does take about 10 to 20 minutes usually for these to come up. I want you to be able to see that process, and then we'll dig down a little bit deeper. So I'll go ahead and launch two target machines in test mode. This is letting us know that we're going to boot these in AWS US East. And then I'm going to choose the latest snapshot. Again, we do have those point-in-time recoveries, so I can go back as far as 30 days if I really wanted to. Okay. And so it's told me those machines are now being launched, and it's going through the conversion process. So while it's doing that, we'll dig down a little bit deeper and talk about the blueprints and what exactly we are going to be launching. So the blueprint, again, is the configuration of the server as we want it to be shown in the target infrastructure. So what size instance we're going to want it to be. If it's on-prem, we're going to have a default instance type. It will be over-provisioned to ensure that we don't spin up a machine that does not have enough resources, but you do have the ability to choose any instance type that you would like within AWS. You can also spin this up on dedicated instances or dedicated hosts, as well as the normal on-demand instances, should you want to do that. And here's where you'll tell us what VPC and what subnet that you want to spin this machine up on. So if you're wanting to maintain the same CIDR block range and you want it to maintain its original IP address, you can absolutely do so. Just have a VPC created with that CIDR block range and tell us to boot on there, and we'll go ahead and spin that machine up there for you. Same thing here, security groups. We want to make sure that we have access to these machines. And if we're wanting to maintain the IP address, we can use copy source. We can also create a DHCP address. We can even use ENIs pre-created with the AWS console should you want to do that. And of course, we have the normal IP addresses, public IP addresses, ephemerals if we want to. Placement groups and IAM roles are all available. And then we have our tagging. So Cloudender automatically tags it with our tags so that you know that we created them. You can also add your own tags to this failed over machine should you want to. We also have our recovery plans. So our recovery plans are the automated way where you can tell us to spin up multiple machines in a specific order. So for application 1 here, we've got our databases booting up first. We're going to wait 0 seconds. So as soon as we click launch, it's going to launch this machine. And then we've got our application server coming up 120 seconds later. Okay, so this ensures that the other machine gets a head start before we start booting up the other machine. And you can build this out again for, you have your Active Directory server booting first, and then your databases and applications. You can put as many servers and groupings of servers in here as you would like. Now, under the Job Progress tab, you can see the steps that the Cloudender tool is using to launch your machines. So here we have an older test that we've gone through. And this lets you know that the test started at about 3:16 p.m. And it went through getting these snapshots, finishing the machine conversions, starting the replicas, and then finished the job at 3:27. So about 10 minutes or so to launch these 2 machines. This is great if you have any issues and you need to do some troubleshooting or want to know exactly where the process is. This will allow you to see all of those steps. We've also got an event log that'll tell you everything that anybody that has logged in and made any changes. And then under the Setup and Info tab, you can come in and see which AWS credentials that we're utilizing, the ones that you've created for us, the replication settings as well. So this is where you can come and set the type of replication instances should the T3 small not be sufficient for replication. The types of replication disks, where these replication servers should be spun up. If you're utilizing a VPN or direct connect or something like VPC peering, you can tell us to not use the public internet and go ahead and use just that connection, as well as any proxies that you may have in the environment that you want us to use. And we have bandwidth throttling to ensure that we're not utilizing too much of your network and causing production issues. You can lock us down to a specific amount of network should you want to. And so as I come back to the machine tabs, you'll see here that under the status, we have target launched. So that lets us know that this machine has been launched within AWS, and we can go to the AWS console and start treating that machine as if it was a production machine. Now, if this is just a test, you can log into that machine, validate that it is talking to the servers that you're expecting. If it is a DR event, at this point, you would repoint your customer traffic to the DR environment and be ready to run as if you were in production. Then once you have finished making any repairs needed to the source infrastructure, whether it's getting the power back on, whether it is the service coming back online, all of that, once that is fixed, you can then do your fail back and send the changes back from AWS to your source infrastructure, and then repoint your traffic at that point. Once that's done and your traffic's been repointed, you can select these machines, click Machine Actions, and delete X number of target machines. and we'll go ahead and clean up all of those spun up instances for you so that you're not paying for those failed over machines when you're no longer using them. Okay. And that is the end of my demo. So we'll go ahead and go back to our presentation here and finish off with just a couple of slides. Here are some Cloudender resources. So of course, we've got our disaster recovery product page within AWS. Gives you a nice little breakdown of what we've got going on. We've got a demo video, which is pretty close to what I just did. But if you want a refresher, of course, that's there for you as well. We are on the AWS Marketplace at this time. And so you're able to just go in there and subscribe to the tool itself should you want to test it out in your environment. We also have some technical training. So this lets you become a Cloudender guru, so to speak, so that you can set everything up, configure everything, and get this up and running without the assistance of an AWS, without AWS assistance. We are, of course, here and happy to help you. If you like to do this on your own, though, you have your own technical training available for you. And we are utilizing AWS Premium support for our assistance. So if you do need any assistance, run into any issues, or have any questions, please feel free to reach out to Premium support. And so some key disaster recovery observations. Using the cloud for backup and disaster recovery provides compelling benefits. AWS provides services and tools for building reliable, fault-tolerant, and highly available systems in the cloud. AWS has partnered with industry leaders in backup and DR to help our mutual customers modernize their practice. And Cloudender provides any to AWS disaster recovery. And as Douglas MacArthur said, there is no substitute for victory. Thank you again for listening to my presentation. If you have any questions, please feel free to drop them into the chat. We'll be happy to answer them for you. Thank you very much.
Thank you very much, Randy and Daniel, for those excellent insights, as well as the demonstration and all the details that you shared with our audience. So I'm going to go through some of the questions that I have here for you. And this one I'm going to direct to Randy first. Randy, I'm interested in exploring disaster recovery with AWS. How or where should I start?
Well, the easiest place to start is if you happen to know your AWS representative, ring them up and start a discussion on DR, and they can engage our DR specialist as needed. If you don't know who those people are, go to aws.com/contact us and enter that you would like to speak to someone regarding disaster recovery solutions, and they'll forward you on. And lastly, of course, I'm always available at siemensr@amazon.com.
Thank you very much. Appreciate you sharing your details there with the audience. All right, I'm using a backup appliance already that is targeting AWS. Can I leverage that in a DR scenario as well?
Most certainly you can. I had the slide there that talked about Commvault. Commvault often uses disaster recovery appliances. There are several to choose from various vendors out there, and that can certainly be a part of the DR plan. I mentioned, the tier 3, tier 2 data. That's perfectly appropriate for that.
Great. Switching gears, I'm going to ping this one to Daniel in the interest of time. Daniel, a quick one for you first. Is the data encrypted in AWS? Very basic one for you.
Correct, yeah. For the Cloudender side, it's encrypted 256-bit AES in transit, and you have the ability to encrypt it when it lands within AWS utilizing your KMS keys.
Okay, and then another one for you. Does the Cloudender agent recognize when size changes are made to the on-premises disks?
Yes, absolutely. Anytime a disk is changed, we will go ahead and change that within the AWS EBS volumes as well.
Great. Well, gentlemen, you've been very kind. Now, I was going to ask, is there a slide that kind of encourages our audience to proceed to the evaluation that you might have that you can share on next steps? Randy, would you happen to have that? There you go.
There
awesome.
It is.
So, yeah, there you have it, folks. There is a survey waiting for you. And if you need an offline, we have an offline Q&A, of course, so we'll be getting your responses back. But we can also do a personalized tutorial for your organization with one of our AWS experts on disaster recovery. So it's going to be an hour-long interactive session. Multiple groups from within your organization and your organization alone will interact with our experts. So it'll be an exclusive one for one group, one organization. And you can simply sign up by posting a note in the Q&A section, or taking that survey which follows, where we ask you that question if you'd like to hear from us to follow up on a personalized tutorial. And one of our AWS experts will be in touch to organize that. So with that, we're going to close out the webinar. Thank Randy and Daniel for their presentation and the information that they shared. Again, drop in a question, even though we couldn't cover it on the call here. We'll make sure we'll get back to you offline, and looking forward to staying in touch with you in some form going forward also. So appreciate it again, Daniel and Randy, and have a wonderful day for our audience, wherever you might be. Goodbye for now.